Okay. Yeah. Good afternoon, friends. Today we'll be talking about this Canvas. How we can deploy Canvas for doing many amazing tasks, including that solar PV cell monitoring. How you do it. So before that, I'll just tell you that nowadays it has become a fad for monitoring these solar PV cells by deploying a drone. The drone flies, and while flying, it takes a photograph. Thank you, EFI, for giving me this opportunity. So far, I have had more than 35 DIYs with EFI and more than 100 with many other national and international electronic magazines all over the world. Well, I always dedicate my presentations to my mom. Well, I was talking that it has become become a fad for using drones for monitoring health of solar PV cells, and where we can deploy our canvas. That will unfold slowly. See, the defects normally happens to this solar PV cells is that one is that crack, another one is the snail trails and hot spots. So cracks happens over the time because of this stones or winds or undergone thrust and stresses. They crack, and when they crack, the most foremost thing happens is that their output reduces. If it is in current mode, current reduces. If it is in voltage mode, the voltage also gets reduced. That strings are reduced of voltage. Snail trail, it happens normally after 5 to 10 years use of solar PV panels. We'll find that small, almost nearly of the same color of the panel, that small trails are running from one end up to the other end or up to the middle. And hotspot, definitely the temperature increases, and that is measured from the back side of the panel. If the solar panels does not contribute fully, the internal resistance increases, then it again becomes heated up, and it, of course, its contribution reduces. So to identify all these three types of defects, so normally what is done today is that a drone takes that picture, and from that picture you have to find out the defective cell. By that infrared temperature will show you high temperature spots and all those things. But really, I have seen it. It does not give you 100% clear picture. So there we can chip in our Canvas technology idea. In my company also deploys this drone. Huge drones are deployed. But really, I'm telling you, at the end of the day, the supervisor has to make a round and to find out whether any panel is burning or not. Yes, a lot of burning takes place. Fire incidents takes place on the back of the solar panels. So you have to be very vigilant. And the main indication you will find if you go through in detail that gradually and slowly over time that contribution of the panel reduces. And of course, this drone technology is not efficient. It's a huge cost of total cost of ownership. It's a recurring cost. You have to maintain a small airfield, and sometimes you have to maintain a pilot also for bigger these drones. So overheads, administrative expenditures, everything goes high with this drone technology. So in that case, if you deploy our Canvas technology, it will be cheap, efficient, and it will be self-explaining. Let's see how. This is a typical Canvas architecture. In fact, if you go back to the history, in 1983, first the Canvas was proposed by Boss. And if you see 1983, the automobile technology, if you see 1983, then 1990s, then 20s, you will find suddenly the cars have become smart car. Because in a modern car, at least 700 to 70 to 100 numbers of sensors are deployed, right from tire pressure, then your anti-skidding brake, then airbag, speed, and starting of engine, lube oil pump, everything is connected with a sensor. And just imagine if you had used so many sensors with so many wires and so many supplies, because every sensor needs to have a supply voltage and every sensor needs to have a signal wire, either it is one wire or two wire or four wires. So for 70 sensors and so many wires, if you had used, the weight of that motor vehicle would have risen by 50 to 100 kgs. But what Boss has proposed, that every sensors will be connected on just two wires. Apart from the supply voltage, for supply requires only one wire, because the vehicle body acts as a ground or 0 volt. So it will be maximum three wires, and all the sensors will be connected on these three wires. And suddenly it is found that vehicle weight is reduced by at least 100 kgs, and vehicles have become more smart nowadays. That's because of CAN bus is deployed. Whereas CAN bus has got a lot of tricks. Mostly there are two types of CAN bus are deployed: CAN bus 2A and B. Here we are talking about CAN bus 2A. The difference is that high bus speed and that bus address, there more payload is involved in bus 2B. Anyway, in the automobile sector, CAN bus, what is deployed, is used for a high speed. And advantage of CAN bus is that CAN bus, when connected with the sensors and each individual node, which can be a computer or can be a microprocessor, and when each CAN bus is connected with each other, no computer is required in between to talk to each other or control each other. All the nodes will be controlled on their own, getting signal, and if once it is decided which CAN bus to get, which CAN node to get, which CAN, means if I decide that one to get signal, one will give signal to node CAN node 2, and when they are connected, then one will be talking to 2. One will not talk to 3, one will not talk to any other node. So everything will be automatically self-controlled. And CAN bus has got one more advantage. Advantage is that CAN bus has got very good, excellent error corrections. And another excellent advantage of CAN bus, that if you reduce CAN bus speed, you can increase the length between nodes to a great extent. I'll show you. And if you increase speed, that length will be reduced. That is one unique advantage with CAN bus. So in the automobile sector, the CAN bus is deployed for high speed, and in other utility sector, it is deployed for fault tolerant. Let's see. This is the mainstay of our project. This is the, you can say, this is the main strength on which our project is standing. This is the bus speed, kilobits per second versus the bus length. See, if you run a CAN bus at 1000 kilobits per second or 1 Mbp, 1 megabit per second, you can send your signal to a node or to a number of nodes up to 40-meter distance only. Whereas if you go on reducing the speed, you see that bus length is increased steadily. And finally, if you go by 5 kilobit per second, you can increase the length between two CAN bus node as high as 13,000 meters. Just imagine. Of course, there is a practical problem. Practical problem is that after, say, 2.5 kilometers or 3 kilometers, the signal strength get reduced. So to cater to that problem, there are CAN bus repeaters are available. So CAN bus runs on two wires, high and low. And these repeaters have only two input and two output other than the power supply. So if you put a CAN bus repeater in between, you can send signals to 13-kilometer length. Practically, on a CAN bus system, you can add 254 nodes. But practically, it is seen that beyond 130, it gives error. So safely, you can go up to 130 nodes on this 13-kilometer length. And the advantage of having the disadvantage of reducing the speed is that your data throughput will be reduced. And of course, if you get say you have 1,000 solar panels, and if you get a signal from the 1,000th panel once in a minute, it won't make much difference for the whole day. And if you deploy your drone, I'm sure you are not going to get your signals once in a minute. So 1 minute to 10 minutes time, you can get all the signals for all the 1,000 panels connected to your solar system. Let's see how. So in Canvas 2A, what we are saying that maximum 120 to 130 nodes you can connect. It just goes in, just 2 pairs of wires will be used. Just 2 pairs of wires. And in between 2.5 kilometers, we will use a repeater. So on 5 kilobits per second, you can go, 5 bits per second, you can go 13,000 meters on 5 bits per second. This is bits per second. And there is a distinct advantage of using CAN bus over Modbus as RS485. In this other bus, you cannot go beyond 32 nodes. That is the address limit they have. You cannot go beyond that. So suppose you have 10,000 panels to measure either current or voltage. If you put some Arduino Ingenuity, you will find that these panels are connected either in series mode or in parallel mode. In parallel mode, you use it for increasing current, and in series mode, you use it for increasing voltage. So you will be requiring only one signal to measure. So for one signal to measure, if you go for 120 nodes, and if you put a Arduino processor in between or mega processor in between, you can find that for each Arduino Mega or Arduino Uno, you can take 10 sensors. Means 10 GPIOs, you take 10 GPIOs, and for each panel, for each GPIO, you put one current sensor or voltage sensor. And there are a lot of current sensors and voltage sensors are available in the market. Per node, you can cover 10 panels. And if you put 120, so per can you can measure 1,200 panels you can measure per can deployment. So you can set up just 9 cans, and I have extended that philosophy more. 9 uploaders I will use, and every data will be uploaded to a common receiver. That I will be telling you in the next slides. And the final output will be beautifully deployed in processing output. Processing, this is for serial data processing. So all data, whatever is coming, whatever is received at the downloader or receiver, it will be put in a processing program, and processing will display it in a beautiful display. And just excuse me for this very rude drawing, because I cannot really could draw it using any software. The broadly what I can be told, it can be told here is that I deployed Uno here, and yes, there is one distinct advantage of CAN is that you can use it in both ways. You can receive signal from your panels, and at the same time, if you find that one panel is not giving full output, it could be because of dust. And if that is the problem, you can use it. You can send a signal through your canvas, so that if there is any roller duster is available on that solar PV cell, you can start it rolling. So these are the relay I have put here. 10 relays you can go straight away, and 10 relays can connect to 10 solar panels, where either it will start showering or it will start dustering. And this is the solar PV panel. And also for powering this CAN node, I have deployed a small buck charger here. Buck charger has got the advantage of that it does not heat up much. It does not waste energy in the form of heat. So whatever 0.05%, I've seen it, it takes hardly 0.05% to 0.1% power it takes from the mother solar panel, and it comes through this buck charger, and it goes to this low power Uno, the 3.3 volt, and then it operates in self-powered mode. And this is the CAN bus, which is nothing but twisted pair shielded cable. Twisted pair shielded cable is normally, you can say, this DC cable. Only it should be shielded. And all this cable will run from one end up to the other end. And CAN bus needs to be sorted with a 120 ohms resistors at the end. Otherwise, data will start reflecting from these two ends. That's a normal process for any coaxial or this type of cables when deployed for signal processing. So this is the CAN bus, this is the slave models. And the self-powered mode, what I have shown here is this. This is getting data from the mother solar panel, going to the buck charger. Either it will be 5 volt or 3.3 volt. And it will go to this SPI based CAN bus adapter. And the CAN output goes to this CAN bus cable. For the master, I have put a keyboard here. And this is the master. Okay. This will upload the data at the end. Or this will act as a self-master mode. This will get signal from its slaves connected along this cable. This is the CAN bus cable. And this keyboard is connected here. Suppose you want to do a showering of cell number 202. So what you will write here, there will be two modes. I'll tell you little detail in the later slides. CAN bus, one is that display mode and one is the control mode. So to take this master in the control mode, control master, then we will punch those cell number with the end command as a hash. And the showering will start automatically on that 202 number panel. And the display mode, what will happen when you put that master in display mode, it will get data from all the slaves. The slaves will give data with their address and then 0 to 1023. This is the 4 bytes. This is the payload. In this 12 bytes, that depends upon the how many address bytes bits you are using. So I have seen if you use the address from 1 to 255, from 1 to 350 or 255, these 3 numbers is occupied in the address format, and the remaining 4 fields 1023 up to 00012 1023 you can send as your payload. And there is a trick there how to use that payload format. Okay, so whenever all the slaves will be sending data through this cable, this master will receive all those data, and it can putting a display here, it can show, or if it is connected to a computer, and in that computer in the serial terminal will receive that data and will display it in the processing output. This is the processing output. All the data will be arriving in the master receiver, and after receiving those data, the CAN bus will be shown in this master processing display output, and the processing display is beautiful. And there you can set all those logics. If this is showing the current, if the current reduces a particular level, this will become red or something, and you can add a lot of alarms here, audio alarms, visual alarms, everything you can do. Processing is a bit easier and very versatile and very beautiful outlook. Okay, now I have extended this idea of CAN bus master receiver. So master receiver, what it will do, it will receive data from all these CAN bus slaves along this 2-wire CAN bus shield. Maximum 130 nodes we can get, and 130 nodes data will come along with that address, and their payload will arrive here, and after all will be put into a small comma separated value string. and this string will be uploaded through this canvas uploader. This is a small SS radio. This will be uploaded. So what happens? You need not to bring any cable from your field up to your control tower or whatever it is. So at the end of all those 10 canvas, they will be uploading data through this uploader. Okay, and see, each UNO can take away 10 panels. 10 panels, all these 10 panels data can go to the slaves. And this is the CAN bus downloader. At the same time, this is the CAN bus master controller. What will happen? This will be getting data from all those canvas uh, canvas strings laid in your vast huge solar array field. This will be receiving data from this SS radio, and this will be connected to a serial terminal where it will be displayed all those processing output. Or at the same time, you can get it connected to a server PC, and server will finally put it in a server display page. So it can be connected to your LAN cable. So that way you can do. And at the same time, these 4 keyboards will be connected in this master downloader controller. And if you punch in your keys here, this will be sent through this antenna, and it will be received by this CAN bus receiver, and it will be again relayed to these CAN bus nodes where it will start showering or dusting. And this slides will end here, and I'll go to the small doc file. There I'll tell you some more tricks. The CAN IDs will be 1, 2 up to 255. And CAN payload is 0000 to 1023 is the maximum payload you can use. CAN the display unit, it can be master on display mode. In the master on display mode, it will be give you output and alarm. And CAN master on control mode, it will shower or dusting control. And in fact, if you understand this idea, you can deploy it in many more utility areas like battery monitoring. Also, you can do. You can do switching in a whole city. You just imagine there are 4 street lights, huge 4 street lights, hundreds of electric bulbs are situated there. You put canvas all in one canvas there, or in 4 canvas there, depending on the sides of your city, say north, east, south, west. Then 4 canvas will uploading data to your control tower. There will be receiving, and they are giving that particular command. You can control each lights of your city. There I'll show you another trick. The whole project started with a 25 kilowatt solar rooftop PV system in one of our marketplace. And there happened that after 2-3 months, the performance greatly deteriorated. So when I was talking to that engineer, he told me that because of a lot of problems, he was also suspecting that battery was defective and many more things. So there I found that because of the dusting, that huge amount of But droppings, the performance deteriorated. When I have seen that on a solar panel, if there is a small But dropping, and you will find that, say in the solar panel, you will find that a lot of diode connections are there in between sub panels. In a whole panel, say a 200 watt panel, in 200 watt panel, there are 4 sub panels, and those sub panels are connected with a big diode in between. So if one panel becomes out, the diode will be connected and this panel output will be bypassed. And I found that a lot of But droppings bypassed many panels. So the immediate solution was cleaning of those panels. Then we thought that why not have a CAN bus deployment here so that we'll understand which panel is malfunctioning. So that way we started with a 25 kilowatt rooftop solar panel. There are 55 big panels. 55, if you connect with this number of watts per panel, you will find that suppliers usually give a lot of buffer capacity. Okay, normally 50 panels is enough for 25 kilowatt. Well, so we deployed Canvas here. Because of this company rights, I cannot show you detail of those projects. but it happened started with 25 kilowatt. We laid that canvas panel there for all 55 panels, and for each these 500 watt panels, we laid canvas, and we found that ultimately that man found that looking at that processing output, he can jolly well finds out very easily which panel needs to be cleaned, and he can do it very easily. It's still operating here, and now we are going for a bigger panel, a 2.5 kilowatt panel for a turbine floor rooftop. We are going for that, but it's a lot of wiring involved there. And in a canvas, advantage of canvas is that it's a very huge error capacity is there, and each panel is self-sufficient. Each node is self-sufficient. They do not need any computer to be helped for getting signal from which panel or going to which node. This is a canvas adapter. This is connected to SPI. For any microprocessors, you can get it connected. It's very cheap and very easily. All the library files are available in the internet. For PICs also, you can connect it. For Arduino, of course, you can do it. For ESP32, ESP8266, you can do it really well. This is the current signal sensor. 30 ampere current sensor signal is enough for each panel. And yes, I told you that your payload is 0000 to 1023. So this is the float value of the load current. And believe me, this is not really required. What you required is that number, this analog read value and minus 512. This is the characteristics of this current sensor. You have to minus 512. Generally, you'll get it. So this number is sufficient. So we are transferring this number only to that processing output. In fact, believe me, if you have multiple sensors, say current and temperature. For temperature, you can put a DS18B20 on the back side of that panel. So for sending two signals, we have to use an Arduino Ingenuity in it 1023. Just imagine 1 and 0. The first two digits you can use for this voltage or current signal. Or 1 and 0 you can use for your temperature signal. Whatever temperature signal you will get, you divide it and put it into a ratio 1:10. And that then the remaining 2 and 3, you can again this current sensor or voltage sensor, whatever it is, you divide it and put it into a field of 1:23. So if the signal is at the ratio of 1, you will send 01. And if it is full, then you will send 23. So that way also, looking at the first two digits and the last two digits, you can define what is the current value and what is the your voltage current value and temperature value. So that way this payload 1023 means 0000 to 1023, you can deploy it, because CAN bus cannot take more load. Or if you send the second data, you have to make another second data stream. So that way you can lose some time there. Then schematic I have shown you. Software is already available with EFI. To download it is very easy software. You can those who know programming, they will understand it very easily. And this is a unique feature. This master on control mode C. This can be helpful for switching your city lights. I also submitted this project in the Prime Minister's Man Ki Baat for city light, smart city light. Look at here how I managed it. See, for sending data 25580, and there is a hash. These are the signals I am sending. There also you can send 4 data, means 1023, something like that. So what I am doing here, see, 255 is the panel number, then I am sending 8 and 0, or I am sending 7 and 1, or sending 3 and 0. What is this? You see here, 25130 is the 251th node, and digital 3 pin, and 0 is the relay off. If you send 3 1, the relay will be on. And hash command I have used only to so that this is the end of the signal. So that way you can deploy a lot of ingenuities in your design. So if you want to do a souring of the 251 panel and which is connected on the third GPIO pins, so you will send 25131 hash. The signal will be sent through the uploader, through the receiver to the CAN bus, and will reach to this 251 node, and the souring will start. That's, believe me, really very easy. And that way you can deploy for street light controlling, for battery monitoring, or for any other. You see that I have seen uh, Mumbai that promenade lightings. For that, they are laying huge cables, say 2 kilometers long seaside promenade, and the lightings, all the lights go into a psychedelic mode, and they have to do a lot of cabling there. So there you can easily deploy canvas. So tens of kilometers long beach light you can monitor. You can do a beautiful psychedelic form using this canvas. You can create a lot of designs and all those things there. This is the schematic that I have shown you. This is the relay where 10 relays are connected for 10 sourings and all those things. Or you can use a separate node for souring also. One node for signal and another node for souring or dusting control. That also you can do. This is the canvas output that I have showed you. And if you deploy a web server, there also you can do it. You have to put a Apache web server. You have to transfer the data in the document root file, then you have to see the output. And this is the canvas output. If you see in the terminal, serial terminal, it will be arriving this way. And the final output is something like that. See, our present project, what it does, if it becomes low somewhere, it will show display in the processing panel. But when you will be handling 100,000 panels, so all these nodes will be given deployed with more intelligence. When a panel becomes less contributing, then it will automatically deploy its own dusting unit or souring unit, or it will show automatically with audio visual alarm in the huge LED TV or whatever it is. So for 100,000s also you cannot deploy LED TV. You have to put another AI sort of thing which will automatically detect, and it will show only the defective panels output. This is the canvas end uploader. This is the master data controller with a keyboard. So for this, what I told you, that double data transfer. If you want to transfer double data from your slave units, then you have to think about these four numbers: 10 and 23. 10 we can use for temperature, and 23 use for current or voltage measurement. So at a time you can transfer double data using one signal payloader. And if you understand this principle, the same idea can be deployed for health checking of battery bank, switching of multi-storied building also. In a hotels, we'll find that lobbies, say 60-floored hotel, 60-storied hotel, there are a lot of common lights which can be controlled by one person sitting at the ground floor or mezzanine floor, whatever it is. He can control all the lights. Same way you can use it for controlling all the lights of a theater. Likewise, the same way we are controlling the showers or this dusting control of the solar panels. Well, that's all what I wanted to tell you.